All right, AP students, today we are going to be investigating Ksp. And so we should have this lab in front of us. Basically, the way that this lab is going to work today is it's sort of a step-by-step lab. You're not just going to watch the video straight through. What you're going to want to do is work a little, watch the video a little, work a little, watch the video a little. The idea is that I'm going to ask you a question and you're going to make a prediction. So for example, if we look at the first one, it says if we mix these two different chemicals together, would a precipitate form? And so the idea is that you will work through that right here and make your prediction. At that point, you will watch the video and we'll move down into A, where I will actually mix those two chemicals together and we'll see if it matched our predictions. At that point, you'll see that the next one says, what would happen? It's another question. So at this point, you will be prompted to pause the video and you'll try and make your prediction. And then you'll start the video again and see how it actually went. So I know that you could technically just cheat your way through this and you could just keep the video running and watch what happens and then make your predictions. But that is really not what we want to see happening, because this is just, it's meant to help you for the quiz, it's meant to help you for the test, and really there's no downside to missing it, right? If you go, did it match your predictions? You could say, no, it didn't. This is what went wrong. This is, you know, what I thought was going to happen. This is what actually happened, and now I know why. And you're good, right? I'm not going to go just like slashing your grade on this. So do your best work, make your best effort here, and we'll see how it goes. So right now, what you should do is begin number 1. It says, if you mixed these two things together, would a precipitate form? Now, be careful about how you do this. Sometimes people think about this qualitatively, right? Just with words. They say, well, look, chlorides dissolve unless they're with a silver letter mercury. Sodiums dissolve all the time. But what about the carbonate and the copper, right? Well, the copper and the carbonate will probably form a precipitate according to our solubility rules. And so a lot of people would just say, yup, a precipitate will form. However, remember that the solubility rules are designed to be at high concentrations, right? They're always, no matter what the precipitate is, no matter what the mixture is, there is some small allowable amount of ion that will dissolve into solution. So the question is, the solubility rules predict it. What does our math predict, right? We were given a Ksp, we're given some different concentrations. You guys should work this out mathematically. So at this point, we're gonna go ahead and pause the video, and in a minute, we'll come back and see if our predictions were correct. All right, we're back. Hopefully you guys were able to do some math. Hopefully you were able to compare your Q value to your Ksp and decide if a precipitate was going to form or not. So now we're going to actually mix these things together. So we have our beaker. You'll notice that we can see the print through the beaker quite easily, and this is a really good way to check for precipitates. If the print becomes very hard to see when we mix the two chemicals, we know that a solid has formed. As far as our measurements, we don't need to be 100% accurate here. We basically just need to get 1 milliliter, and when we use these pipettes, there's actually a line right here for 1 milliliter. Okay, so we're gonna go ahead and we'll start with the copper chloride here. So we need 1 milliliter of it. So I'm just gonna fill that pipette to about 1 milliliter. So we'll squirt that in. And then we need to fill the other pipette to 1 milliliter. Get as close to that as I can. And we'll squirt that in. And then once the two have been squirted, we can kind of swirl it a little bit. And if we see when we hold it over the writing, we can see that it definitely becomes really, really difficult to read. So there's definitely a precipitate inside of here. So hopefully your prediction matched that. So now what we want to do is move into letter B, and we want to predict what would happen if we add HCl to this mixture. So what's going to happen to this precipitate? Is more of it going to appear? Is it going to go away? Is it going to stay the same? And explain. All right, now that we have our predictions, we want to actually add the HCl to the mixture and see what happens. So we've got our dropper bottle with some HCl. We can see that it's pretty foggy. Maybe along the edge we can see some writing, but not much. So either that writing is going to get easier to see, it's going to get harder to see, etc. So let's go ahead and start putting some drops of HCl in. All right, what's happening here? So adding the HCl, looks like it dissolved the precipitate. It made it more soluble. Right. So we've pretty much finished number 1, A and B. Now it tells us to clean out our beaker, and we're going to remix that precipitate. And instead of adding HCl to it, we're going to add NH3. What do we think is going to happen when we add the NH3? So we're now moving down into actually adding the NH3 to our mixture. So this time we have a bottle of ammonia, and this stuff is a mess. It's a little powder everywhere. So when we look at it, let's try and get on the borderline there. Again, we can kind of see some of the clear, a little bit of the foggy. We're going to add the NH3, see if that print gets harder to see or easier to see or stays the same. So we'll start putting a couple of drops in. Okay, so we're getting a color change here. What's happening to the print? So we got a color change and it got easier to see. Right? We got a nice dark blue. It went crystal clear though. So what does this mean? Well, if I can see through it, there's no PPT and it got really, really dark blue. So what the heck is happening here? Now we're going to go ahead and take a second, and we're going to move up to the front of the classroom, and we're going to take a look at a saturated MgOH solution. All right, so for the next part, it tells us that we need to take a look at a saturated solution of MgOH2, so that's what I have here. We can tell that it's saturated because I formed a precipitate, and that precipitate has sank to the bottom, and I have actually let it sit for several nights. So this is the liquid on top of it here is as dissolved as it can possibly get. Most of it is remaining as a solid down below, but there are going to be a few ions up in this solution. So what I'm going to do is very carefully pour off some of the liquid up on top here. We can see there's a little bit of liquid up here. We're going to pour this off into a beaker so that we don't get any of the solid, just the liquid off the top. And we're going to take the pH of it. So we're going to go ahead and, oh no, I put a wet beaker down on my paper. So we're going to gently pour some in here without getting any of the solid. So we see a nice clear solution. There's a little bit of chunks flying around in there, but not very many, not enough to mess up our sensor. So at this point, we'll just sort of step over a little bit to our pH meter. And so we can see that the pH sensor here, right now I have it in a buffer. The buffer is 10. I was checking to make sure that it's reading correctly. So we're off by a couple little decimal points, but not very many. I'm just gonna rinse any of that buffer off, get it down into the beaker here, and we're gonna go ahead and take the pH. So we're going to just kind of let this thing go as far as it can, kind of jumping around here a little bit. I know it's usually around 10 somewhere, and that's why I used a pH buffer of 10, so we could kind of see where it falls. Hopefully it was accurate. Just let it sit for a second. Looks like it's kind of stabilizing right here. So let's go ahead and record 10.25 seems pretty good to me. So let's go with 10.25. All right. Okay, so at this point, we've got our pH of our saturated solution. We have a few steps that I'm going to walk you guys through now. We want to first find the pOH of the solution. There's an important reason for us to find the pOH, right? Hopefully, we can use that pOH value to find some of the ions we need here and use those concentrations to find our Ksp for this particular solution. Once we have the Ksp, we'll flip it over, and I've listed the theoretical Ksp here, and we want to go ahead and do some math and try and figure out what pH this would have predicted. So we'll see the pH we got, and we're going to compare that to the pH that we actually got, and see if we can talk about the error a little bit. So at this point, you don't need me and the video anymore. Good luck, you guys. Let me know if you have any problems.